Welcome to part 2 of lecture 8.1, Definitions and Common Roots. So in our last lecture we went over several common roots. This time let's put them in action. So let's find the following roots, if it is indeed possible, to the 6 examples. The cube root of -8, the cube root of -27, the square root of -4, the negative square root of 4, the fourth root of -16, and negative fourth root of 16. For the first equation, for the first problem, the cubed root of -8, since it is an odd root, this is allowable to take the root of a negative number. I can rewrite -8 as -2 cubed. And because this cubed root and cubing basically cancel each other out, I'm left with -2. So the cubed root of -2 cubed is -2. So let's consider the cube root of -27. Again, I can rewrite -27 as -3 cubed, and the cubed root of a cubed will cancel each other out, leaving me -3. So the cubed root of -27 is -3. Now the square root of -4 is not real because I can't take an even root, which the square root is an even root of a negative number, at least not yet. But I can take the negative of the square root of 4, which is -2 squared, and therefore it is -2. And I just want to be clear, the 2 came from the operation of the square root. The negative was hanging out front. For e, the fourth root of -16 is not real because it is an even root, but I can do the negative of the fourth root of 16. The negative fourth root of 16 can be written as the negative fourth root of 2 to the fourth. The fourth root and the fourth power cancel each other out, leaving me a 2, but it is the negative of 2, giving me -2. Let's simplify the cubed root of 125a cubed. Well, I can write this, the cube root of 125a cubed. 125 I can write as 5 cubed. So the cube root of 5 cubed a cubed, I can write the radicand, what's inside the radical sign, as the whole quantity 5a cubed. And again, the cube root cancels out the cubing, leaving me with 5a. Let's simplify the square root of x to the 6th power. I can rewrite x to the 6th power as x cubed squared. My whole goal is that I can cancel something out, so the square root will cancel out the squaring, leaving me x cubed. Now, the previous examples were fairly simple to work through, but we're going to get a little bit more complicated. So expressions involving the product of a number and a radical. Those would be something like 3 radical 2, 1/2 radical 5, 5 radical 7, 3x radical 2x, 2ab radical 5b. Now I do need to explain to you, between the 3 and the radical 2, there is an implied mathematical operation. It is multiplication. It's the product of those two values. So it's 3 times the square root of 2, 1/2 times the square root of 5, 5 times the square root of 7, 3x, which is indeed there's an implied product there, so it's really 3 times x times the square root of 2x. And then of course 2 times a times b times the square root of 5b. Here's what we can do with that knowledge. Okay, let's try 3 square root of 2. But that's implying 3 times the square root of 2. And the square root of 2 is an irrational number, but I can get approximation for it. So if you plug it into your calculator, you'll get approximately 1.414. And I can do 3 times 1.414, and that's approximately 4.242. So let's use a calculator to find our decimal approximation of the following examples. So the square root of 12. Now I just have my phone calculator out here, and I'm going to use the square root. Let's turn it on. The square root of 12. And for my calculator, I just work forward. It's approximately 3.464. The second equation is going to be 2 times the square root of 3. That's going to be 3.641, and so on. If I wanted to know just what the square root of 3 is, I could say the square root of 3 is approximately 1.73. But since I am plugging this into the calculator, I can do the whole entire equation at one time. So let's try the square root of 45. 6.7 approximately. And then 3 times the square root of 5 is going to be 3 times the square root of 5. That's going to give us 6.78. Okay. So again, the square root of 12 is approximately 3.461. The square root of 2 square roots of 3 is 2 times the 1.732, so approximately 3.464. Square root of 45, plug into the calculator, you're going to get 6.7.08. 3 square root of 5 is approximately 3 times 2.236, which is 6.708. Okay. And if you've noticed, the square root of 12 is 3.464. Likewise, 2 times square root of 3 is approximately 3.464. The square root of 45 is 6.708, and 3 square roots of 5 is 6.708. This is not a coincidence, by the way. Here's the reason why. Because the square root of 12 is really the square root of 2 times 3. But the square root of 2 times 2 times 2 times 3 is really the square root of 2 squared times 3. I can break these apart, and we'll learn about this rule in a future lecture, but I can break these apart to where I have the square root of 2 squared times the square root of 3, but the square root of 2 squared is 2, giving me 2 times square root of 3. That's exactly what we have up here. The square root of 45 is really the square root of 3 times 3 times 5. But 3 times 3 is really 3 squared. So I have the square root of 3 squared times 5. I can break these apart to where I have the square root of 3 squared times the square root of 5. But the square root of 3 squared is 3. So I have 3 square roots of 5. Now let's consider the expression 4 plus 6 square roots of 3. If I gave you 4 plus 6x, I think you would know what to do with it. I think you can bring out the GCF and factor it. Well, let's consider the same type of problem with 4 plus 6 times 3, the square root of 3. Treat the square root of 3 like an x, like a variable. If that's the case, 4 is 2 times 2, and 6 is 2 times 3 square roots of 3. So I can factor out the greatest common factor, which is 2. So 4 plus 6 square roots of 3 turns out to be 2 times the quantity 2 plus 3 square roots of 3. It's the same exact process if it was 4 plus 6x. and I asked you to factor out the greatest common factor. Then you would have 2 times the quantity 2 plus 3x. So think of it maybe like a variable, and it will be easier to work with. So let's take an expression and simplify it. So 3 square roots of 5 divided by 6. Well, 3 square roots of 5 divided by 6 is really 3 square roots of 5 divided by 3 times 2. But in all of our division, if I have the number over the number, it just reduces down to 1. So I can, in essence, cancel out or reduce by division of 3. And so my final simplification is square root of 5 over 2. Now let's think about 4 square roots of 2 over 2. Now no, I can't cancel the 2 in the radicand, but I can do something with the whole numbers on the outside. 4 is 2 times 2, square roots of 2 all over 2. I can cancel the 2's out, reduce it by 2, leaving me 2 square roots of 2. Let's work with another problem. 4 plus 6 square roots of 3 all over 4. Again, with this problem, I can't just cancel out the 4's. I have not only addition, but I have this radical sign. Treat it like an x. I can't just ignore the x. But I can factor out the greatest common factor. And from there, then I can simplify. I have a 2 in the numerator. I have a 2 in the denominator. I can reduce by 2, leaving me 2 plus 3 square roots 3 all over 2. Let's try one more for good measure. 10 plus 5 square root 6 all over 5. Greatest common factor is I can factor out a 5, leaving me 5 times the quantity 2 plus square root 6 all over 5. 5 over 5 is just 1, so I can reduce, giving me 2 plus square root of 6. Here's a problem that I'd like you to do before our next class session. So please simplify 12 plus 3 square roots of 7 all over 6 and turn it in before our next class session. So that's the end of part 2. Until part 3, be seeing you.